I started the lecture by talking about the results of the exam. The median was around 71 or 72, and I will curve the final composite score in the course, not the exam itself. However, if the rest of the exams came in the same as this one did, then roughly an A would be 85 to 100, a B would be somewhere around 66 or 67 to 85, a C would be somewhere in the neighborhood of 50 to 55 to 66, 67, and a D and an F would be less than 50. Now again, this cannot be used as the actual curve for this exam because it will also depend on how everyone performs on the labs and on the remaining exams. But it is a curve that would roughly apply to this exam if all other exams and labs were like it. I then started to go into the explanation of the exam problems, and I forgot to start recording. However, as it picks up, it is very near the beginning of the start of my midterm explanations. So here it goes with the rest of the lecture. I'm recording. Okay, so separate compilation means that you compile each of your .cpp files separately using the -c flag, and then you have a final link step where you use still the G++ compiler and the -o flag, but now you are linking the .o files. And you'll often hear the professors in this curriculum refer to .o files. And those are the object files that are produced by the -c flag. So these are called object files. And that's important for you to know. I know that Dr. Plank provided you with makefiles, and I'm afraid the fact that he gave you makefiles has kind of meant that you simply use the makefiles without actually understanding how separate compilation gets done. In fact, some of you just put make down there, and make is not separate compilation. Make is project management software. And you give make rules for how to do separate compilation, but you have to understand how to do separate compilation in order to write a make file. So any questions about that? Yes.
I'm just really confused. At part C, that statement is the same thing as the three statement at part D. Why would you usually use the statement at part D?
Why write three statements rather than just one? The reason is when you get to a large project, let's say it has 150 files, okay? This statement recompiles all 150 files. Not only that, you'd have to have a line that was 150 files long, but it would recompile all 150 files. That could take several hours. Whereas if you separately compile them and you change one file, it might only take, say, 30 seconds to recompile one file. And then this statement here would take maybe another minute or so. So instead of taking 3 hours, which is what this statement would take if you had 150 files. So the idea of separate compilation is in really large projects, you only want to recompile the one file that you changed. You don't want to recompile the hundreds of other files that didn't change, because that takes a lot of time.
Yeah, I understand that. So you're saying if I only change one of the file in the hundreds file, I would just use the G++/C and then use the /o to link the file I changed.
That's right.
Any of the file that is already.
All the .o files now would have to be on this line right here. So if there was 150 of them, you would have to list all 150 .o files. That's why you use make. Because make, you do it once in make, and then you never have to do it again. So yes, you do see make files that actually have a gigantic number of .o files. But you only had to do it one time, and then you give rules, and then in the make file, there are individual rules for making each of the 150 other files.
So you're saying the statement at C is slower than the one statement, the last statement at RD?
This one is
Yeah,
much faster than this one, because this one first actually, so this one actually performs these 3 steps. Okay? This one right here does all 3 steps. Okay, so that's why. In this course, it will never matter. The extra, even if you don't change this file, it might take an extra half second and you'll never notice. But in the real world, believe me, you will notice. Okay? So that's why we emphasize separate compilation, is because as your projects get bigger, it becomes a lot more important. And eventually we'll tell you actually how to create your own makefiles, but they're kind of complicated, so we put that off to a different course. Is it covered in 360? Or don't you know? No? Interesting. Okay. Okay, next one. Most of you did fine on the hashing problem, except some of you had a little problem with quadratic probing and how to place 61. It turned out that many of you just tried to use linear probing and it works except for 61. So you were asked to hash these keys into a hash table of size 13. So that means that 22 hashes to location 9, because 22 mod 13 has a remainder of 9. So 22 goes into 9, 28 goes into 2, 39 goes into 0. There's 39. 48 hashes to location 9, and because 9 is already occupied, we have to do 9 plus 1 squared mod 13, which is equal to 10 mod 13, so 48 goes into location 10. The next one was 41. 41 wants to go into location 2, but it's already occupied by 28. So then 2 plus 1 squared mod 13 is 3 mod 13, so 41 goes into there. So 61 was the last one, and of course, your handy-dandy CS140 instructor made sure that one would be problematic. So 61 mod 13 is 9. Okay, because 4 times 13 is 52. So 61 wants to go into location 9. That's no good. Plus 1 squared gives us 10, but 48 is there. 9 plus 2 squared mod 13 is 0, but 39's already there. So 9 plus 3 squared mod 13 is 18 mod 13. And finally, we find the happy resting ground of location 5. Okay, so this one, most of you did pretty well on. The only 61 seemed to cause any of you any real difficulty. That was not so much the case with 4, although I was very pleasantly surprised with how well, in general, you all did on this, because this wiped out the students 2 semesters ago. So it's still worth going over it because many of you still had some issues with this one. So I'll just say a couple things. First of all, many of you would have gotten it right if you did the K before the C, but you did the C first. That just was a slight oversight that got you 1 point off. So what you first had to do was translate 13 into base 2, and that is 1, 8, 1, 4, 0, 2s, and 1, 1. So it's actually 1101. and you're actually using 8-bit characters. So you're going to have to pad the 13 with 4 zeros, like that. So initially, this is what H is. Then we left shift it by 2 bits, which mean that the leading 2 bits go away, and we add 2 bits to the end, which means that really, if we divide it in half, we got that wrong. It was right there. So what it really was 0011 0100. Now, most of you correctly were able to translate these hexadecimal digits. So K is 6, which is 1412 and a 0. And the B is 11, which is an 8, no 4s, a 2, and a 1. And now some of you did bit arithmetic rather than exclusive OR. Exclusive OR, 0 and 1 is 1, 0 and 1 is 1, 1 and 0, 0 and 1. So they're all 1s. Then 1 and 0 is a 1. But 1 and 1 gives you 0 in exclusive OR. So that's the outcome you come out with step 1. And this translates back to 5F. Now, some of you forgot that at step 2, H had changed and that you had to left shift the result from step 1. Some of you simply left shifted 13 again for step 2. That got you a 2-point deduction. You have to, the second time through the loop, H has changed. It's now H is equal to this. So again, you have to knock off the leftmost 2 bits and add 2 at the end. So you get this new number right there. And you're going to exclusive OR that with C, which is, again, 0, 1, 1, 0, and 3 is 0, 0, 1, 1. When you exclusive OR that, you get 1s there. 1 and 0 is 1. 1 and 1 is 0. 1 and 1 is 0. And is 0, so you end up with 1F. Okay? Almost all of you did your work, which allowed me to give you partial credit. A couple didn't, and I was just stuck because I couldn't really give partial credit if I didn't see your work. So this was certainly something where it helped to not only show your work, but try to label your work, because if you don't label your work, I really have trouble figuring out what's going on. But I was able to award a lot of partial credit here because many of you did show your work. Okay, 5 also managed to get a fair number of you. So on A, the issue was the notcn.eof. We just do not want you putting it inside a while loop because it is not proactive, it's reactive. And so if you do write the code this way, the last CN statement here will succeed. If I have 10, 20, 30 along with, say, A, B, C, the first time through the loop, it will read A into name and 10 into salary, and it will print out A and 10. The second time through the loop, it will read B and 20 and print out B and 20. The third time through the loop, it reads C and 30, and now it comes back up. And because CN is reactive and not proactive, EOF is still false. So we come in for one last read, which fails, leaving the original values in name and salary, and hence we print out C and 30 a second time, which is wrong. Our preferred solution for that is to eliminate this statement and simply move line 4 into the while loop so that it becomes while CN into name and salary. Okay, some of you said put a CN before, that you had to put a CN before the loop, and that you had to also move this read after the cout. That's fine. That got you full credit. Some of you said that you had to put this in parentheses, and actually that's not correct. In this case, the time when I said you had to put in parentheses was if you were saying not CN into something. Then you have to put it in parentheses in that case. But in this case, it was fine not to have the function call in parentheses. Some of you said, well, you didn't check for to see whether the name or salary was correct, but that was not the issue here. The issue was that cn.eof. We wanted you to remember we don't want you using cn.eof inside a while loop. B ran into the problem that I did not have the HTML right, and it was supposed to be vector int data, but unfortunately the HTML ate the less than greater than signs. Fortunately, most of you didn't notice that fact. So the real problem was supposed to be that it's not passed by reference. Okay, you need to pass your vectors by reference. You need to get in the habit of passing objects in general by reference, but definitely passing vectors by reference. So the code was inefficient. Okay, some of you did note that this was an incomplete type, and you got full credit for telling me. I winced, but it was an incomplete type. Actually, I think I took a point off if you didn't tell me that it was by reference, but you otherwise got full credit because, in fact, it is incorrect. It's not a full type. Some of you said that you cannot divide here by data.size, that you actually need to keep a counting variable, but that's wrong. The counting variable will come to the exact same count as data.size, while wasting a lot of time counting itself. So in fact, dividing by data.size there was a perfectly legitimate thing to do. So questions about B. Okay, and then C. Many of you figured out that CN was jammed if the was not an integer. But the issue is that before you can try to clear it, you have to first clear the jam by calling cn.clear. So between lines 10 and 11, you had to put cn.clear in order to clear the jam. Many of you correctly said you needed cn.clear, but you wanted to put cn.clear after the cout, and that's too late. The order is very important. The clear has to go before the read statement. Because if you don't put the clear before the read statement, CN is still jammed at line 11 and the read will fail. Some of you said that the clear statement has to go after every CN, but that's false. If the CN succeeds, there's no reason to do a clear. So you only have to do a clear after a bad read, so it only had to go into an else. Some of you figured out how to simplify the code. That was fine. all for simplification. I'm not going to show you how that might be done because I thought it's half dozen of one, half dozen of another. But in simplifying, you also had to tell me how to correct it. And most of you who simplified it also told me how to correct it. And most of you did pretty well on the last one. So I didn't take off any points. Like I said, I accepted this because on the Hydra machines, that's how you do it. But on Macintoshes, you have to do it this way. You have to give a relative name with the dot / That actually wasn't the big problem. Many of you forgot that you used a single less than. I had doubles in some cases. It's a single less than. Some of you gave me two separate commands. So some of you said editor less than data.text. And then you said editor greater than result.gif. But unfortunately, what that does is it executes it twice. The first time, it reads it from data.text, but it prints to standard out. Then it executes it again, this time reading from standard in and sending it to result.gif. I wanted a single execution that read the input from data.text and wrote it to result.gif. Hence, that was the right way to do it. So again, the reason we're doing it this way, is we do want you to learn your command line tools. That was one of the goals of this course, is to teach you command line tools. So questions 6 and 2, we're teaching you about command line tools. 1 and 4 are getting you into the specifics of machine architecture. They're kind of a review of 130. Question 3 is our data structures question. 5 is teaching you how to read code and detect inefficiencies or inefficiencies or incorrect code. Basically, remember, a second goal of this course is to make you better C++ programmers. So passing objects by reference to make things more efficient, not using this silly EOF statement because it causes you problems, knowing how to clear jams in CN, and how to clear bad values out of the input stream. So at any rate, I'll take questions actually after class if you have them. I want to move on into today's lecture topic, but I'll be more than happy to take questions after class. I also have office hours today from 3:30 to 5:30, so feel free to stop by then as well. Okay, so today we get into, we kind of go away from pointers for a little while, but we're going to circle back to pointers. And I also want to note one thing. I don't go over everything that is in the notes, but I expect you to be familiar with what's in the notes. So for example, I did not go over the pointers to vectors because I felt like we'd gone over enough stuff that you should be able to figure out how to point to vectors. If you can't, by all means, ask me how to do it and I will tell you. Also, there was this sorting using the STL. Okay? It was buried in his notes, and I expect you to look at it, but it's very trivial. You include algorithm, and then it's a very simple line you call the sort method, giving it begin and end. The reason I did not cover it last time was I would have had to go over what begin and end means, and I felt it was premature. We're going to go over that either today or on Tuesday. So I decided I was going to put it off for another week. But you're still responsible for it. I just think it's not that hard. And so I don't go over everything that's in the notes in class, but I still expect you to know it. Okay. So, thus far, you have seen one way to store a list of items. Okay, so we talked about hash tables, which was how to find things. But there's also times when you want to keep a list of things. Okay, one of my favorite examples is a grocery list. You want to keep a list of groceries. Okay, another example actually is email. Okay, this is actually a list here. And you want to be able to do things to a list. Like if you have a grocery list, you add new things to the list. Okay, if you're going through the grocery store, maybe you have oranges, apples, maybe you have orange juice, milk, Coke. And as you go through, you maybe cross things off. So you want to be able to delete things from the list. So you want to be able to add things to the list, delete things from the list, and notice that I am deleting from the middle of the list. That's something that you really haven't had to do up to now. Same thing with email. Let's see. I really don't care about the fact that my funds transfer is now processed, so I'm going to delete from the middle of this list. Okay, so I don't always delete from the front of the list or the back of the list. Sometimes I like to delete from the middle of the list. Well, so far you've had a single data structure that allows you to store a list of things, and it is an array or a vector. Actually, I guess two things, but they're fundamentally the same. So here you might have oranges, apples, OJ, milk, and Coke. Now, there's a problem. Okay, so before I say the problem, what are vectors really good at? What have you used vectors for? What operation have you used a lot with vectors? You've added things. How? Using pushback. And where does pushback put an element? At the end. So vectors are very efficient when you want to add things to the end. So let's say I decided that I also wanted to get, let's see. Well, I like cantaloupe, but that takes a lot of spelling. I like pomegranates, but that takes a lot of spelling. Ooh, I like ice cream. I'll still write it. Okay. So it's very good for adding things to the back. Vectors also turn out to be very good for removing things from the back. Okay? We'll get to such a data structure in a bit. So they're good when we add things to the back and remove things from the back. They're not so good when we remove things from the middle. So let's say we want to remove apples from the middle of the vector. What we have to do is then move all the elements that are to the right of it, one element to the left, in order to avoid creating a hole in our list. Okay, it's now good to have holes in our list, so we have to move every element that's to the right of the deleted element, one element to the left, and that's inefficient, because we may have to move up to n elements. Right? If we delete oranges, we're going to we have to move up to n minus 1 elements. We could move up to all of the remaining elements in the vector. So it turns out that vectors are not an efficient way to store a list if we want to be able to remove items from the middle of a list. Okay? So, remember we did have pointers. So, there is a different kind of structure called a linked list, where each item points to the next item. It's called a linked list. So here we would have oranges, and we would have apples, and we might have OJ, milk, and Coke. And if you could see what the data structure for storing this looked like, we would create something called a, say, class list node. And it would have two protected variables. One would be a string for the item, and one would be a pointer to the next item, which is a next list node. So we'd say next, and it would point to the next list node. Okay, so if we wanted to add, let's say that we had a pointer to Coke. Okay, I'll call it tail. So let's say we have list node tail. For the moment, I'm going to make this protected because I don't want to have to get things super, I don't want to have to deal with methods just yet. So I'm going to make it public for a moment. So I have list node tail, and I'm just having it point, I'm going to pretend it points to Coke. How it got to point to Coke, we won't worry about. We want it to, it points to Coke. And we want to add ice cream to the list. So what I would do is I would have another thing, list node, new node. And I could say new node equals new list node. And now I could say new node arrow item equals ice cream. Remember, the arrow is what we use to access a field in an object that is pointed at by something. Now I could say that tail next equals new node. So this statement creates a new node. This statement assigns ice cream. This statement makes the next field point to ice cream. And finally, we would say new node next equals null because it doesn't point to anything. It's the last item in the list, so it doesn't point anywhere. So this is where pointer variables start to become valuable, because they can be used to point to other objects. And you'll notice that while before we were having pointer variables point to pre-existing stuff, so we'd say like int star p equals ampersand a, that's not the real advantage of pointers. Having pointers point to named variables isn't particularly useful unless our goal is to make our code hard to read. I mean, why say star p equals 10 when a equals 10 is a much more direct way to write it? So while we introduced pointers by having them point to named variables, that's not where they're useful. pointers are useful for pointing to unnamed variables, that is, to memory or to objects that is allocated off the heap. Okay, because in that case, those memory blocks or those objects are unnamed. So this is where our pointers really come into their own. We can create new objects dynamically and link them together. Okay, so that's all well and good, but all I did there was add to the end of the list, which is what I could do with a vector. So the question is, well, how about inserting into the middle of the list? Well, that's just as easy. Let's say that here I wanted to insert ice cream after apples. Okay, as long as I had a pointer to apples, so let's say I call it PTR for pointer, I can insert it after apples very easily. Okay, so I just changed my code a little bit. Okay, I'll get rid of tail. And I will call it pointer next. And here, instead of making new node next equals null, come on, give me a cursor. There we go. I want ice cream to point to OJ. So new node is next needs to point to OJ. So I can't set its field to null anymore. I need to set it to something that points to OJ. So I need to get a pointer to OJ. What points to OJ? Apples. Okay, but I can't say apples. Can't say apples next because that's not the name of that object. That object is unnamed. But what does point to apples? PTR. So we say actually that, so we know that apples points to, so we'd like to be able to say apples next, but we can't because apples is unnamed. But pointer points to apples, so in fact, we can write here pointer next because pointer points to apples. Yes.
When you had to do the last and the second to last lines in the opposite.
I might. Did I just mess this up? You may be right. Just a second. Yes, actually, this is an excellent point. Order is incredibly important. Okay, when I set here pointer next equal to new node, I actually destroyed the original pointer to OJ. I actually make pointer next point to ice cream. So in fact, I have to do it in the opposite order. I need to now say pointer, wait, see, a sec, new node next equals pointer next. And I have to say pointer next equals new node. If I do it in the opposite order, then I'll have changed pointer next so that it points to ice cream, right? Let's say I do it in this, let me do it, show you the way I originally had written it. In the way I originally wrote it, I said pointer next equals new node. And then I said new node next equals pointer next. This was the way I originally did it. But right here, what did I set pointer next to? New node, right? What is new node? Ice cream. So then when I say new node next down here equals pointer next, I'm just making new node point to itself. That's no good. So the order in which I do my assignments is incredibly important here. For those of you who like math, it's not a commutative operation. Okay? This is really important. This is why you often draw diagrams when you have to write code that involves pointers, because order becomes really important. Just as a thought, this occurs a lot. Might appear on the code reading portion of midterm 2 as an example of code that is incorrect. So you just might want to remember this as a common error, because Dr. van der Zanden might circle back to it on midterm 2. Okay, so it also becomes fairly easy to delete things from this list and to do so efficiently. So before, it seemed that it was pretty inefficient to have to move every element one item to the left. So now let's say that I want to delete apples. Okay? So let's say that I have a pointer here. I'll call it, and I'll call this apples pointer. So I have two pointers, one to the node before apples and one to apples itself, and I want to delete apples. Okay, well, what I'll do is make oranges point to OJ. So I'll say pointer next equals what? How do I make oranges point to OJ? Pardon? Yep, apples next, because apples pointer points to OJ. So if I say apples pointer next, I make oranges, so this makes oranges now points to OJ. So this is my comment. Make oranges point to OJ. Okay? Once I've done that, I simply say delete apples pointer, and we're done. Because it returns the object pointed to by apples pointer to the heap. And when I'm done with that, it gets rid of that. And voila, we're done. So it took two statements as opposed to the multiple data moves we needed with a vector. So lists are linked lists are a lot more flexible. Okay, so we're going to use linked lists a fair amount in this class. Now, actually, I've gotten a bit ahead of myself, but I felt it was important to show you a bit about how linked lists are implemented. We'll actually circle back in another week or so to re-examine, or actually in more than a couple weeks. After spring break, I believe, is when we look specifically at how linked lists get implemented. But I felt it was important to give you a sneak preview here of the way we implement lists. Okay? So that you have that you know that their underlying implementation involves pointers. Now, the STL, the standard template library, gives us a data structure called a list. And in fact, that is a linked list. So if you include list in your program, that will include a data structure called a linked list. And now you can create, here we're doing it, we're creating a linked list of lines. And we can store things onto either the front of the list using push front or onto the back of the list using push back. Okay, it's very inefficient to add a new element to the beginning of a vector. We have exactly the problem before. If I want to add a new element to the beginning of the vector, there's only one way to do that, and that is if instead of subtracting I were adding, I would have to move everything one element to the right to make room for my new element, and that's very inefficient. Whereas in a linked list, it's very easy. If I have a pointer here to oranges, you should be able to easily create a new node and make it point to pointer. It's no big deal at all. I'm not going to do it, but it's very simple. Actually, I am going to make you do it right now. Just take a couple minutes. Suppose that I have a pointer PTR to oranges. And let's say I want to add ice cream before oranges. So I want to add it to the beginning of the list. Just take a couple minutes on a piece of paper or on your computer and see if you can write the code to do that. And I'll even help you out. I'll show you some of the code you've already seen. Maybe I won't, because I already deleted it. Okay, you've got to give it a try on your own. Hopefully you wrote it into your notes. So just take a moment. You're trying to add ice cream to the front of the list. So you first have to allocate a new node, and then you have to make new node point to oranges, and you have this variable called pointer, PTR, that already points to oranges. It's fine to talk to your neighbor too if you want. This isn't something I'm making you hand in. Okay, so I know you may not quite have gotten it, but kind of need to move on. So you should have a pointer you declare as a list node star. Then you have to create a new list node using the new. Actually do it like that, new list node. Then you need to make new node arrow name equals ice cream, sorry, item equals ice cream. And finally, to add it to the front of the list, you say new node next equals what? You need it to point to oranges. And what points to oranges? PTR. So those four statements suffice to add a new node, which is ice cream, to the front of the list. Does that make sense? Yes.
Why do you call them this?
To create a new, so I'm doing that because I need to create a new instance of a list node, and what that's doing is calling the constructor.
But you didn't have a constructor.
Right, so if I don't have a constructor, I get the default 0 argument constructor. So if I don't provide any, if I don't declare a constructor, C++ by default gives me a 0 argument constructor. So what I'm doing there is invoking that default 0 argument constructor. That's all that's happening. I believe I could leave the parentheses off, but just for safety, I'm not. Does that make sense what's going on? So the list tells it that's the kind of object I want to create. Yeah. This tells it, so let's say that I had two constructors. Let's say I had one that was list node 0 argument constructor and one that was list node that takes a default item. So I'll call it value. So then I might want to actually, in that case, have passed in ice cream as the initial value. So that would show you an example of where I'm calling, in that case, the one argument constructor. So when you create an instance of an object, you're allowed to, a constructor gets invoked. and you're allowed to designate which constructor you want to invoke. So the empty pair of parentheses says I was selecting the zero argument constructor. Okay. So, going back to the notes, lists are very efficient at inserting into the front. So we have a push front operation for a list which does not exist with vectors because it's such an abomination. Okay, but with lists, that's efficient. So what we're doing here is we're trying to reverse a list or the lines in a file. So for example, if I have 10, 20, 30, 40, I want to print it out as 40, 30, 20, 10. So what I'm going to do as I read them in, I'm going to be adding, so I read 10. Then if I add 20 to the front, where does it go? If I read 20 and add it to the front, here's 10. Does it go to the left of 10 or the right of 10? To the left, because it goes before 10. Push front adds to the front. Then we read 30, add it to the front. We read 40. You can see that what happened is by always adding the next line I read to the front, I reverse the file. Then the second thing I have to be able to do is iterate through my list. And this is where C++ unfortunately uses confusing and brain-damaged syntax, in my opinion. If you get Dr. Greger for 302, he will disagree with me completely. He loves the syntax that they use. Dr. Planck and I don't, but it is what it is. So, if you want to traverse through a list, you have to call what is called a iterator. You know how we've talked about iterating through a loop, so that's where the name is derived from. So you declare this animal called an iterator, and you'll see that you have to give the type of the iterator, which in this case is it's an iterator for a list of strings, and then you say : iterator. You'll have to memorize it. And LIT doesn't stand for literature, it stands for list iterator. So then there are some methods that allow you to access the beginning and end of the list. Okay, before we do that, let's take a look at what these things really do. So internally, way down here, so this is a list of less than and greater thans, but it gives you the idea of what's going on. So the L.begin returns a pointer essentially to the first item in the list. So L.begin returns a pointer to the first item in the list. However, L.end does not actually return a pointer to the last item in the list. It returns a pointer to something called a sentinel node. So a sentinel node is not a node that is actually in the list, but marks either the beginning or end of a list. So a node that is not part of a list but marks the beginning or end of a list. By the way, I know that I'm now using node. Node refers to node equals one element of a list. So you're going to hear me use node a lot. So it is, or the thing that stores. It's really, node is the object that stores one element of the list. So in this case, the Sentinel node is not strictly considered to be a node that stores an element of the list. Instead, it is a node that marks either the beginning or the end of the node. So L.end returns a pointer to a node that marks the end of the list. Okay. There's also a way to iterate through the list in reverse. So if we want to iterate through the list in reverse, there is a method called rBegin that returns the last element in the list, or really a pointer to the last element of the list. And there's L.rEnd that returns a Sentinel node that marks the beginning of the list. So that as you count down, you know when you've reached the beginning of the list. So this list has two Sentinel nodes, one marking the beginning of the list and one marking the end of the list. Those two nodes technically do not hold a list element. They're in some sense part of the list. So I shouldn't really, they really are part of the list, but they don't contain a list element. Okay? We clear about that? Okay, so going back, so what happens is if we have this list right now, it really looks like this: 40, 30, 20, 10, and X is just meant as a Sentinel node. So when lines.begin, lit points to 40. Now, if you think of lit as a pointer, by dereferencing it, you get the value of the list, which in this case is 40. So in this case, we use the asterisk to dereference the value of the list. Or that list node, I'm sorry, that list node that lit points to. Now when I say lit plus plus, that advances the lit pointer so it points to the next node in the list. And so when I now say star 30, we already had printed out 40. Now we print out 30 because lit points to 30. Now again we say lit plus plus, making lit now point to 20. And when we execute the star lit, it prints out 20. Then again we say lit plus plus. Now it points to 10. So we print out 10. Now we say lit plus plus and it points to the Sentinel node at the end of the list. And that's the same as lit dot or lines.end. That's the node or pointer that lines.end returns. Lines.end returns a pointer to the Sentinel node. So when lit becomes equal to that pointer, we drop out of the loop. So you don't have to deal right now with the messiness of pointers. Right? So here we're doing it in reverse. So here we're adding the lines to the list using pushback, so it becomes X, 10, 20, 30, 40. But now we print them out in reverse by starting lit at r.begin, which is a pointer to the end of the list, and we go backwards till we get to here. And as Dr. Planck points out, this just looks idiotic. What do you really think we should be doing with lit if we're going backwards? I would think it would be a decrement.
Yeah, why don't you just use a regular iterator then?
That's a good question because I don't think it works.
Well,
We'll try after class, but the point, Gavin, the point is if you're using a reverse iterator, you still have to use plus plus. That's the point I'm trying to make here, is that whether you're using an iterator that goes forward or an iterator that goes backwards, you have to say plus plus. Otherwise, it doesn't work correctly. So just remember it. Write it down, please. Whether you're going forward or backwards, use plus plus. Okay? Okay. We'll pick this up on Tuesday. Same set of lecture notes for Tuesday. And good luck. Remember that you have a bit of an extension on the first part of Lab 5. It's due tomorrow night. Okay? Still just do first part tomorrow night, second part next week. Yeah, but here, let's do it, okay? It seems like it should work.
starting at the end with the regular iterator.
Yeah.
And going until.
Okay, let's try
You're
both.
saying you always have to.
Yeah. Just a sec. Let's just do it for fun. Just a sec, Jaja. Give me 1 second. So first let's try it in reverse, but let's do minus minus. Okay? Okay, and I'll create my input. Nice. And we'll run it. It only printed 40. No good for the minus minus. Now let's try going. The problem with going in the beginning is it's going to start at the beginning. So if I say r equal lines.begin, and now I say equals end, the problem is lit is equal to the beginning first element. So it didn't even like it. Give me a compile error message.
Yeah, if you use a regular iterator and you start at the end, you still can't just subtract.
Nope.
That's what I was.
So let's try it. How would I do that though?
Just use a regular iterator.
But what am I going to give here? End?
The end.
But then that points to a non-existent node. Okay, so now you want me to say you can't. Okay. Let's see. Let's try lit. It doesn't work because I can't. Let's try this. Lit equal lines dot end lit minus minus. Now we'll get rid of that. Now that's what you want me to do. So I had to make it lit minus minus should now make it point to the last item in the list, right?
Okay.
You buy that?
Yeah.
Okay. It's still going. Let's see. Yep. No viable overload for that.
String at the top where it says reverse underscore iterator. What's the difference between reverse iterator and just iterator on?
Oh, yeah, let me actually try that because it was declared as a reverse iterator. Good point. Let me get rid of that. Okay. Now let's try it. So for lit equals lines.rbegin. That need the word iterator. Yeah. it just won't buy it. I think the problem is as soon as you declare lit as an iterator, it won't work with rbegin because it knows rbegin works with a reverse iterator.
Okay.
So it's pretty. Gavin, bottom line is stupid, 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 but that's the way it is. Jaja, you were. Okay.
Will you look at this for me?
Absolutely. Programmer never clears.
How's that minus open loop operator working for you?
Not at all.
It should work.
It doesn't. It should, but
Not
it
for
doesn't.
reverse iterators.
But it doesn't work. So with a forward iterator, it doesn't work either. Maybe if you start it with R.
Rn minus 1. What size that?
No, because that returns a number. Size of returns a number, not a pointer. Size of will in fact return the size of the list, but it won't return the right thing.
Yes, but if it's a pointer, then shouldn't it technically be an integer you subtract by the number of bytes?
Yes, but it will return like 5, which is a pointer to.
Some garbage memory. We don't want that.
We don't want that. It will return. It will give you a bus error at its next. So generally, sake faults occur when you access an invalid piece of memory. Bus errors occur when it's not divisible by 4 or 8.
Makes sense.
So no, it's not working. I plan to go back to my office and see if I can't figure out a way to make it work. But it's spoiled every effort thus far. Yeah, so I'm guessing what happens is that you can start moving it forward and then use minus minus to move it back. But what you can't do is set it equal to something like r dot n because r dot n expects to be rn expects to be used with a reverse iterator. So there's a type mismatch. So I think you could probably start at begin, push your iterator all the way to the end, and then start saying minus minus, but that would be horribly inefficient. Like I said, I plan to go to my office and see how I can break it, but I need to deal with my children, as Dr. Plank says first. If you find a way, send me email too.
All right.
I'd be interested.
Well, I think I have something on my GitHub. I'll let you know.
Okay. String, right. This would result in incorrect error output, as well as using a lot of memory.
The second part is probably wrong.
Okay, so it's also this part. The problem is you didn't say
I didn't explicitly say.
you didn't say never clear CN.
Okay.
Clearing the string back. I'm willing to give you a couple points back. I see what you're trying to do, Todd.
Okay.
So it basically was 2 points for giving me the reason and 3 points for the fix. So even though your wording is,
Yeah.
I'll give you 2
I'll
points. If you'd said clear CN, you would have gotten 2 points.
Okay.
Okay. Then saying CN dot clear and where it goes would have got. Then saying CN dot clear would have gotten you 2 more, and saying that it should go before line 11 would have gotten you 1 more. So
Okay.
that was kind of the grading guide. So I'll give you 2 points back.
Okay. Thank you.
So you're welcome. Let me go blank screen and do that before I forget, so I don't show. So yeah, it doesn't. The part about the wasting memory is not correct. What happens is it will just keep spinning endlessly, trying to read that bad value, and you'll be in an infinite loop. But you'll never take up any more memory. You'll just be in that awful infinite loop.
Okay. See, I would think it would just go to the next position in memory.
Nope. That's the. You would think, but it doesn't. That's why we keep emphasizing that idiom that you have to clear, then read the thing, and then move on.
Okay. Thank you.
You're welcome. Do you have an exam
should be
question
pretty
or
quick,
lab
yeah.
question? Okay, I'll take it.
Okay, so it says 56.
Mm-hmm.
This says 46. A little bit of a mismatch.
Right. Sorry, Sam.
That's kind of right.
Hope you didn't see that before class. Or did you?
I did.
Sorry.
quite
Makes you
alright.
think, at least you probably felt a lot happier when you saw your
Yeah, it was quite It was
exam.
very much a relieving experience.
Yep. Whoops. Well, now you have a
Oh,
66.
that'd be awesome.
There you go.
Thank you.
Very nice on the exam. Well done.
Thank you.
Thanks for pointing it out. I'm really sorry.
It's quite alright.
They want us to create a new vector of HT back. And then like, I'm gonna show you my code. This is my code. So I was thinking I can open the table, the vector by vector, and then push every element from the table vector to our vector.
Code?
I don't, is that like my misunderstanding about the assignment or?
No, that's looking kind of good. Let's head out because Adam needs to get in here. But that's looking like I need to take a slightly closer look. What are you talking about, Adam? What are you talking about today? Assembly language? Cool. I understand. Well, that's still better than looking at Intel
Yeah.
assembly. That's kind of a nightmare.